Welcome everyone to this FieldView webinar. We're going to be talking about FieldView 20, the new version that was released late last year, and helping you get to know FieldView 20. So with that, I'm going to pass things over to Yves-Marie. And again, thanks everybody for joining us. Enjoy the webinar.
Thank you, Shane, and hello everyone. So yes, today we're going to give you a brief introduction about our new version FieldView 20. I've grouped the topics into 3 categories, looking into interface improvements, performance improvements, and brand new capabilities. And as Shane mentioned, we'll handle questions at the end of this presentation. This will take us about 30 minutes before we get to questions and answers. Before I start talking about the new version itself, I do want to touch on our new website, and especially on the customer portal, which is brand new. So if you've gone to our new website, you may have seen our new identity. We have a lot of material, old and new, on this website, so I encourage you to come and check regularly. We have things like documentation, for instance, that is now accessible through the open side of the website. We have FAQs, lots of videos, past webinars, and this is where this new one will be posted as well. You can see as well on the homepage that we have our new mission statement, which is to produce a tool that is high quality of output, that is fast, easy, and reliable, and I hope that will show again in the work that we've done this year, working on FieldView 20. And if you go over here to the top, customer portal, that will take you to this new website as well, where you can get not only the downloads, but you can also report a support problem and edit your customer information from the profile section. So what's important here is that all customers will need to register to this new portal. Because of GDPR, we were not able to carry over the contacts from the old website inherited from International Link. So we're sorry for the inconvenience, but really this new platform and new web server are really worth it. Much faster download time, for instance. So we encourage you to register to it. Okay, so with that, let's get into FieldView 20 itself. And I will start talking about the interface because obviously if you've installed and started FieldView 20 already, you cannot have missed the new look. As you could tell, we have redesigned all of our icons. And so that kind of stand out the first time you started. So why did we do that? Our past icons were coming from a lot of different sources and various eras. So it goes for a design that was a bit inconsistent and very different looks, a little bit all over the place. What we wanted here was to have something that was more consistent in design. You can see that it fits our new graphic identity which is mostly blue, and it allows us to have important information stand out by using different colors and mostly red. So we hope that it's going to make FieldView faster for new users to learn, that the important information will pop out more for them, and it will be easier for them to understand the meaning of each one of these icons. Don't worry if you're an existing user, the locations remain the same, the design is very similar, so you will not have to learn a new interface, not at all. And in addition, we also took advantage of this effort to add buttons to add icons for buttons that were text only so far. As I'm discussing the interface here, I do want to say a word about 2 other improvements. The first one is related to the file browser, specifically on Windows. Here we're looking at the new file browser on a Windows 10 machine. It comes with a lot of new capabilities because it's using now the native file browser from Windows itself. So you have a new search bar that's very convenient. Say you want to look for one of your restarts, you don't recall where you stored it, you can find it this way. You have a very convenient, quick access, customizable menu on the left. Here you can see, for instance, that I have set up quick access to the directory where I have all of my data sets. So that's very convenient. On top of that, you also have improvements related to performance for the file browser. You may have noticed that the previous file browser was sometimes slow, especially in two cases. When navigating to a directory on the remote drive, that could be very slow. And when navigating to a directory with a lot of content, a lot of files in it. So those two problems have been addressed, and for those cases, you have much better performance with a new file browser. And finally, regarding the interface, we've made an improvement to the filter bars. So you find them in a lot of places in FieldView. Basically, anytime you have a long list, we let you filter the list based on strings. And the behavior change that we've made was to make all of them case insensitive. We made that for two reasons. First, this is really the standard in software. And so we think that this is what users were expecting. And secondly, it makes sense for CFD as well. See this application here, where I'm trying to filter the list of variables and want to pop up everything that is that has pressure in it, right? I want to look at the different forms of pressure. Just have to type in the beginning of the word pressure, and everything comes up, whether it is uppercase or lowercase p, and I'll not have to worry about it when I type it in. All right, so with that, let's move to more of the meat of this presentation and start talking about some of the performance improvements that we've made in FieldView. So you may be wondering, how can we continue to make FieldView faster while we're already at the 20th major version of FieldView? And so one of the keys is to try to find the performance where we can find it. And it's obvious that systems have been changing a lot. If we compare today's CPUs with some of their predecessors, especially if we compare the kind of CPUs you find on a workstation or a fat node or post-processing node on a cluster, you'll find that the number of cores on these CPUs has increased dramatically. So that gives us an opportunity to gain performance through parallelization. And at that stage, you may be thinking, well, I believe I heard about FieldView using parallel for quite a long time, and maybe you're yourself using FieldView in parallel. And the answer is yes, FieldView has been using parallel for quite some time, since version 9 actually. Just to give you some context, when version 9 was the current version, cell phones looked just like that. So that parallelization, all that time, has been used on MPI and a parallelization on the grid. So making the assumption that your data was partitioned by the solver, the partitioning will be maintained as the results are saved, and we could count on those grids for load balancing the effort. So that works great on a wide spectrum of machines. And for a number of versions now, we've been providing up to parallel 8 with all standard licenses of FieldView. So as I mentioned, MPI parallel really gives very good results, and that's really the main way of doing parallelization in CFD. But in post-processing, it doesn't always work well. So let's have a quick look at how MPI parallel works for a post-processor, and why would they have to do more work in that regard to gain additional performance from parallelization. So in this simple example, we are looking at a multi-grid case. And again, FieldView is counting all those grids for load balancing the work between multiple parallel workers. So once you've done that, each one of the workers has a portion of the mesh in memory. And let's say that you want to create a cut plane that goes through a number of them. So each parallel worker will create a portion of that cut plane. The portions will then be grouped by the master, and the client will be doing the rendering. So as you can see here, all the workers are working at the same time, and you can expect good parallel speed up. For parallel 8 on a typical workflow, we often say that the speed up is in the range of 5 to 6x when you work on a typical system and dataset. But again, as I was mentioning, not all operations benefit of parallel in the same way. And a very good example for that is to look at what happens for a streamline being computed in parallel. So we'll take the same case of MPI parallelization and now look at a streamline. It's very easy to understand that a streamline can only be in a single grid at a time. So that means that you have a single worker computing it, and the other ones are just idle. And just with that, you can understand that MPI parallel is far from ideal. And actually, if you tried before and did some timing, it was not unusual when running in parallel to see FieldView be slower at computing streamlines compared to running in serial. So that's the reason why we picked this first capability for our candidate for working on multi-threading. And that's something we did in the previous version, FieldView 19. And to look at how we did it, I'm going to simplify a bit the case and first look at a single grid case. So if it's single grid, we're going to assume that all logical processors are seeing the entire mesh. And what we can do is a different form of parallelization. What we can do is use threads to compute streamlines at the same time. So if we have a bunch of streamlines that are going to be computed, each one of the threads is going to work on a different streamline, and that's how you get your speed up. So again, this is what we did in FieldView 19. And if we look in this quick video that is here showing us a streamline computation, you will see in the CPU history at the bottom that all CPUs are being used by default. Doesn't matter whether the case has been read in serial mode or in parallel mode in the MPI sense, all cores will always be used. And that's how we got this great performance improvement. So now let's mix it up a bit and say that the same case was loaded in parallel from the MPI point of view. So again, the grids get load balanced on the parallel workers. And now the same logic of having multiple lines computed on each parallel worker can be applied with multi-threading. And so you can have a combination of MPI and multi-threading happening at the same time. And that's how we obtained this about 13x speed up that was typical for streamlines going to FieldView 19. So this is how we learned about multi-threading technology. We gained our experience. And after 1 year, we had more confidence we could go further. To tell the truth, we actually didn't have a single bug report from our user base from computing streamlines in this way. So we really had the confidence to go forward. The first thing we did in FieldView 20 was to extend this work to a type of dataset that wasn't covered for multi-threading in FieldView 19. That is cases with arbitrary polyhedras. In FieldView 19, we were automatically switching back to single thread for streamlines. It is no longer the case in FieldView 20, and so no matter what type of data you have, even with hard polys, you will benefit from multi-threading. Then we continued our work. And the capability that is closest to streamlines in FieldView is what we call surface flows that you see with these black lines in this image. We have multiple types of surface flows. Some are actually really streamlines limited to the wall. So those are the ones that we call earlier. We have offset surface flows that are computed at the distance from the wall, and we have no slip that are then computed based on wall shear. So you see that we get a really good speed up across the board, a slightly smaller speed up for no slip, just because we have some overhead with the computation of wall shear, and not all of that operation could be parallelized with multi-threading. That's still a very satisfactory speed ups that we get. And then we continued this effort and looked at other parts of FieldView that could be multi-threaded. And we have another group of features that we worked on. So basically, all the formula operators have been improved, separation and reattachment lines, and vortex scores as well that you see in this image in the bottom left corner. So if we go back into the details of formula operators, what I'm showing on the histogram on the right is comparison between FieldView 19 in gray, showing the time it takes to compute a given formula, and the bar in green is the time it takes now with the new version, and you can see the speed up on the right. So what it shows us is that first, there's speed up for all operators, no exception. And secondly, the bigger the CPU overhead for computing a formula, the bigger the speed up as well. That's great for people using formulas like Q-criterion or Lambda 2, especially for looking at big isosurfaces of turbulence. You're going to get a great speed up with this. Just want to mention that the parallelization we've done is a bit different than what we did for streamlines, where it was obvious to just do a thread, well, to balance the lines on the different threads. Here we are doing a mix, depending on the application, where we are doing balancing based on the grids and also on the nodes. So again, that means that if you have a single grid, you will still benefit from this improvement. All right, so to sum it up, what I suggest is that we look at the speed ups we can get on a typical case. So this is a real life case here of a structured overset wind turbine simulation with 46 million nodes. And the post-processing that we've timed has been done on a typical workstation with 32 cores. And we'll look at the time that it was taking in FieldView 19 and then in FieldView 20 to do the same work. So we'll start from there. And first compute surface flows on the boundary surface. It goes from 22 seconds in FieldView 19 to just 4 seconds in 20. On top of that, we compute separation lines, shown here in red. This goes to from 12 seconds to 3 seconds. Same result for reattachment lines, shown here in green, 12 to 3 seconds. And finally, computing vortex scores inside the volume. And these go from 29 to 21 seconds. So again, smaller speed up because of some overhead that we have. In this case, the vortex scores are, well, a part of the calculation is a little bit of a black box, so we are not able to parallelize all of it, but still some improvements for all users. Finally, let's compute Q on Q-criterion on this case and plot an isosurface for it. You can see that it's very large isosurface, and the timing goes from 20 to 10 seconds. So if you recall from the earlier slide, I was telling you about 10, 11x speed up for computing Q. That was for computing the formula itself. Once that's done, you still need to compute the ISO, and here where I'm giving you the timing for the full operation. So clearly, the isosurface computation is dominating in this case. But what's great is that this is one thing that is really benefiting from the earlier parallelization, the MPI parallelization. So if I were to compare serial FieldView 19 to parallel FieldView 20, I will see a great speed up because I can combine the MPI speed up and the multi-threading speed up. And to prove the point, what we can look at is Q not on the big ISO, but instead on the cut plane. So we're coloring the same cut plane here based on Q. And the timing goes from 13 seconds to just 2 seconds because the the function calculation itself is so much faster. So another way to summarize it is to look at a side-by-side video on the next slide. We got FieldView 19 on the left, FieldView 20 on the right, and we'll do the same thing just to show you the ease of use. I don't have to worry about how the data has been read. I just pick a variable, so Q in this case, that we're going to render on the cut plane. So on the right, you can see that all cores are automatically being used. On the left, since that case was read in serial, there's only one core working, and that will give us a big difference in performance. FieldView 20 took about 15 seconds to compute and render the variable. And we're not going to let it play to the end, but FieldView 19 was taking over 3 minutes to do the same thing. So again, we've gained a lot more experience and confidence in our ability to use multi-threading. And so you should expect even more features coming to multi-threading in next versions of FieldView. We still have low-hanging fruits on our lists that we do want to address. But at the same time, we also wanted to take the opportunity in FieldView 20 to experiment with new technology. And so we looked at other ways to get better performance. And an obvious one that has been a big trend in our industry has been to push operations from the CPU to the GPU, which is a common operation. You have a lot of shaders functions now that are reliably supported on all types of graphic cards. And so we thought it was time that we started to experiment with it. So the first capability that we've been looking into is related to vectors. What you can see on the right here is a set of 2D arrowheads. And you can see that as you change the view, FieldView is automatically adjusting the arrowheads so that they're always flat to screen. The idea is that we want them to be well readable. So that operation, we call it internally billboarding. And that's something that in the past was done on the CPU. By moving it to the GPU, we are getting to a point now where we have interactive speed, as you can tell. And the good news again is that it will work on all graphic cards. We tried that on a variety of cards, including laptops with just an Intel chip instead of the GPU. And the shader has been working beautifully and gaining speed up on those systems reliably as well. So if we do the same thing and have a matchup, FieldView 19 and FieldView 20, yeah, I'm afraid doing this through the web, the performance on the right doesn't show up too well, so you'll have to take my word for it. But we've timed a performance difference of 50x moving to the GPU for this operation. And so it took us to a point where we even wanted to change the defaults. So if you use vectors in the past in FieldView, you may have noticed that by default, you don't use those nice 2D heads. By default, we use 3D heads because they are faster to render. And when you were shifting to 2D heads, FieldView was automatically using the motion whenever you were changing the view to be fast at re-rendering. So you can see here, we render 2D heads. If you change the view, we go back to 3D heads and so on. But it means that you could not have this nice view in previous FieldView versions. Now it is so fast that we've changed the default. If you make vectors on the plane or on the surface in 20, we'll automatically use 2D heads instead, and there is no more demotion applied by default. That makes the much more readable 2D heads a lot more usable in this new version. All right, two more items on which we've worked on performance that I want to discuss very quickly. The first one is related to transient cases. So we've made improvements in FieldView to avoid touching surfaces that do not update in time if you're changing the time step. So that's especially interesting with the workflow we've always been recommending when making unsteady videos like this one. So the best performance you can obtain with this video is to have extracts loaded in FieldView, and I'll describe again in the next slide what we mean by that. But if you have just a surface, just a cut plane for all the type steps loaded in FieldView, and you use another extract for the car, if the car isn't changing over time, then that's really how you get the best performance. And so starting with FieldView 20, in a case like this, where only the plane is changing over time, when you sweep on time, the car will remain totally untouched, and that will give you about an order of magnitude speed up comparing FieldView 19 to FieldView 20. And a final word on performance, again about XDBs. So we've made FieldView faster for writing and reading XDB files. So we have a number of customers who use XDBs as a productivity tool. The idea being to run FieldView potentially in batch, to take the large data sets and make smaller extracts. So in a case like this, it's super useful to have a set of extracts for the car, and then you make other extracts for X, Y, and Z planes. And once you've done that, you can use your smaller files, the smaller XDB files, for making all your images automatically. So for customers who use XDBs as a productivity tool, we now have a new option, which is to write XDB files without encryption, and it gets activated with an environment variable. And it gives you a 20% speed up on output and input, both of them. Now, if you're not using XDB files in this way, but instead more for sharing your results and potentially for letting people load their results in XDB view, you don't want to go to this format, which will then be incompatible, so you should stick to the default. All right, let's move on to the last section of this presentation, where we're going to discuss actual new capabilities. The first one is related to the use of zero thickness surfaces. They can be quite common in CFD solvers. They are used for different things. It can be what people call baffles, meaning that you simplify a geometry and a wall becomes really zero thickness, and you could have flow on both sides of that wall. Another common application is what people call thermal shells, meaning that you could have solid on one side and fluid on the other side. So it leads you to a position where you have collocated nodes with different values for the same variable, right? In the case we're looking at over here, we're looking at the diffuser of a sports car. Pressure will be very different on the inside and the outside of the baffle. In previous FieldView versions, there was only one variable we could show at a time. Meaning that even trying to render both sides, one was taking precedence over the other one. So FieldView can now handle that by default. And in addition, we've provided the capability to switch, to flip front and back, if you realize that you're not looking at the right value. So going back to this diffuser over here, the vertical fences in the diffuser show colors, so variations in pressure. And you can see that on the top. The uniform blue value shows us that we are looking at pressure, but on the inside of the car, not the outside. So we just simply activate flip front and back to overcome this problem in the interface with the solver. And now at the bottom, we have a matching pressure value on the diffuser that goes well with what we see on the vertical fences. So a quick demonstration to show you it works. In this video, we have a notional sail case. The flow is coming from the left, going to the right. So for a sail, you will expect high pressure on the inside, that will be red, and low pressure on the outside, that will be blue. In FieldView 19, all you could see initially was red on both sides. And so what we could do to show the low pressure side was to change the selection and keep only the low pressure side in the binary type selection. But now we're seeing only the blue and no more red. So let's look at it in FieldView 20. You can see that by default, with the same surface selection, we have high pressure on the inside, low pressure on the outside. And so that's good by default coming out of this solder. But let's assume that we want to switch it because the solder has the normals flipped. You can just activate the flip and show the opposite of what we were showing by default. All right, one last new capability I want to mention. This is something we actually already introduced in FieldView 19, but that was at the time limited to unstructured datasets. The feedback was really good, so we did the extra work to support it for structured datasets as well in FieldView 20. So it is the ability to have boundary surface clipping. It's been a long time request. People wanted to have the ability to clip the surface based on either XYZ or theta Z for cylindrical coordinates, on top of doing thresholding on a variable. So that's not doable. Let's look at one last video in which we are looking at a wind turbine. And so what we'll do is use a new clip section of the boundary surface panel. And so we can use a slider to try to isolate the blade. We can also type in a value for Z. You can see that the surface is updating automatically. And so here we're working with cylindrical coordinates because I wanted to show you how we can work on different values of radius. That will especially be useful for looking at the various forces we get based on the radius, and this sweep could be automated in a script to make a plot of loads against the radius, for instance. You can see that the tab changed to green. Clip is now in green to show us that the clip is activated. So even if you move to another tab, it will remain green to draw your attention to the fact that you have an active clip. All right, so with this being slightly over, I'm reaching the end of this quick introduction. So again, we've made a lot of work to try to make FieldView a faster tool. This is actually, again, the fastest FieldView to date. We have an improved interface that we hope will be easier to use. And we have a number of new capabilities, and all of that with a tool that we hope is going to be just as reliable as you've known it so far. And so if you want the full details on this new version, the What's New in FieldView 20 document is available as a PDF from the new website. And don't forget to visit and register to our new customer portal to get access to all of this material. All right, so thank you for your attention. And with that, I'm going back to you, Shane, for the questions.
Okay, great. Thank you so much, Yves-Marie. As I mentioned to everyone, there is the ability to ask questions. We have had a few questions already, but during this Q&A period, you can ask questions using that the interface there. So we've had a couple of questions related to parallel and the difference between the MPI parallel and the multi-threading. One of the questions is there any particular setting for parallel to enable parallel when you launch FieldView 20? That's one question for you, Marie.
Sorry, I missed the beginning of your question, Shane.
Okay, is there a particular setting you need to use when you launch FieldView 20 to enable parallel?
Okay, no, absolutely not. So we try to use all the cores all the time for the capabilities that have been parallelized with multi-threading. What you do have is the opposite. If in case you want to limit the number of cores that we're using, there's an environment variable that will let you limit it. That could be useful, say that you're typically using your workstation for something else, like grid generation, for instance. You could totally do that. But otherwise, we're going to use all the cores all the time for multi-threading.
That's multi-threading. And then what about MPI?
Well, for MPI, then it doesn't change. We haven't touched that. You need to go to the data input menu. And before you load your case, you have to select one of the parallel options. and that's how you select on which system you run the server. And if that's a local server, for instance, you can pick the local license parallel option, and that will run the maximum number of parallel servers depending on your license. So up to 8 for a standard license, but we also have options for more servers. And so that will be the maximum of that and the number of cores that you have available on your system.
Okay, thank you. Another question, actually related questions about performance speed ups for streamlines. I know that you said that we implemented the speed ups for streamlines in version 19. Was there an additional improvement in calculation or of streamlines in version 20?
Yeah, that is the main thing. And yeah, looking at this question and the user asking it, I know he's mostly using FieldView in parallel. So I anticipate that some slowness that he could have seen was mostly due to parallel streamlines. You know, I didn't go in all details, but there are plenty of things happening with parallel streamlines. One of them is that when your streamline reaches the end of a grid, you have to find which grid it should continue in it. And so that's some overhead. And we worked specifically on this overhead as well with multi-threading. So there's been an improvement there. And so, yeah, overall, for streamlines being computed in large cases, you should see an improvement with FieldView. Most of it was already in 19, but if you had our police, that will be told in new for you with FieldView 20. And it was not at all implemented in earlier versions, so FieldView 18 and before.
Okay, and then the second part of that question is that if you calculate streamlines and then you add a few more and recalculate, it appears that the entire rake or all the streamlines are recalculated. Could you comment on whether that's true or not?
Yeah, this is true. This is true. It's true that we could cache what has already been calculated, but we haven't made this optimization. Our experience is that this is, well, unless a very large number of streamlines are being used, hover several hundreds. But if you work with a sample of streamlines, typically this is something that is pretty quick. So it didn't seem to us like a good investment to work on the caching, but rather to work on the overall speed up.
Okay, we have another question on the same theme of streamlines. Will a streamline released from an unstructured mesh go through overset Cartesian multi-block grids?
Is the question whether it will go through it?
Yes.
Okay, yeah, I'm seeing the question. I had one limitation here that FieldView will not have streamlines jump from one dataset to another one. So if the Cartesian of a set has been read as a separate case, then it will not jump from the unstructured case to the Cartesian multi-block. It is, yeah, from the person asking the question, I anticipate that this could be related to the create solver. Maybe we should take it offline, but specifically for create, there is a version of FieldView called FieldView Create that works a bit differently using a different server and has the ability to read multiple cases as one. So the unstructured mesh and the Cartesian of a set. And so in that case, streamlines do go from one mesh to the other, and it's actually even the case for other features like cut planes and isosurfaces with that version are created as a single surface. So that's a more general feature, but this is not currently supported in the standard FieldView version.
I can also ask that if you do have any questions you think about afterwards, you can always send us an email. send an email to sales@fieldviewcfd.com, and we'll get that question answered. Okay. Well, Yves-Marie, thank you for a great presentation, and thanks everybody for joining us today.
Yes, thanks everyone.
With that, we'll end the presentation and say thanks again and see you next time.